In this next video, we're going to be looking at forces which cause a centripetal acceleration. Before we move on and see what forces actually cause a centripetal acceleration, we're going to have a little quick recap. So, Newton's three laws of motion. So Newton's first law of motion: an object at rest would tend to stay at rest unless acted upon by an external unbalanced force. This goes for saying motion as well. An object in motion will tend to stay in motion unless acted upon by an external unbalanced force. So this is Newton's first law of motion. So let's look at an example of this. If I have a rock, this rock is just sitting there nice and comfortably on the ground. He's quite happy just sitting there. He's a rock. So this rock here, if I don't apply any external unbalanced forces on it, he's just going to sit there quite happily. Alright, let's look at motion then as well. If I have myself a rocket and it's sitting there floating around in space at the moment, I then fire this rocket so it starts to move. If I don't apply any external forces onto this rocket and I run out of fuel in the rocket's going to continue on in the same motion that it was before. So this is Newton's first law of motion. Newton's second law of motion is F is equal to ma. The force acting on an object is directly proportional to the mass of the object and the acceleration. So you can rearrange this formula to find out the acceleration acting on the object, and that's just simply A is equal to F on m. And Newton's third law of motion. Newton's third law of motion is that for every action there's an equal and opposite reaction. So my example here, if I have a gun and I safely fire this gun, I'm going to have a projectile going outside the muzzle. It's going to keep on flying off. So that's our projectile. So that's one force. The reaction force to this is that when I fire the gun, I'm going to be pushed backwards slightly. This is because the force needed to get the projectile out of the muzzle has a reaction force which is pushing back on me. So for every action, there's an equal and opposite reaction. Okay, now that we've had a recap on Newton's three laws of motion, let's move on to the forces that actually cause the centripetal acceleration. So if we look back at my last video, we know that a centripetal acceleration is the acceleration causing uniform circular motion. The acceleration is pointing always to the centre of the circle of motion. So, the forces causing uniform circular motion can be a number of things. They can be a tension force, they can be a frictional force, there could be a normal force, it could be any number of forces that cause the motion of the particle or object around the circular path. So how does a force cause this acceleration? So if we look at Newton's second law of motion, we see there's a directly proportional relationship between the F and the A, so the force and the acceleration. If we have a force, we cause an acceleration. So if we have an acceleration pointing towards the centre of our circle in uniform circular motion, this is caused by a force in the same direction as this acceleration. So my force is causing my uniform circular motion must be always in the same direction as the acceleration, which is pointing towards the centre of the circle. So this force is not simply just a centripetal force. There are actually forces caused by some other reason. So, the frictional force, so if I have a car going around the corner, the frictional force is the force that keeps the tyres on the road and causing that car to go around. There's nothing holding the centre of the circle to the car. So there's no string or nothing holding it there. There's only a frictional force between the road and the tyres. So this frictional force is giving us our force causing centripetal motion. Okay, if we saw the other day that I had a tennis ball on a string. This tennis ball on a string has what we call a tension force. So the string has a tension in it, which is holding the ball in motion around the circular path. So this is the tension force causing our centripetal acceleration. A normal force. So we'll get a bit more into the normal force in the next video, but normal forces help us go around a bank curve. I'll say that for now. We'll get into this in more detail in the next video. Another force that leads to a centripetal acceleration is gravitation. So gravity, or the force of gravity, can cause an object to move around a circular path. Think about the moon and the earth, or the earth and the sun. The moon is orbiting around the earth. This is caused by gravitation. The earth is moving around the sun. That's caused by gravitation. Satellites moving around the earth are going in a circular path, the same as the earth around the sun and the moon around the earth. They're all travelling in circular paths, therefore they have a uniform circular motion. This force causing this uniform circular motion is gravity. We can also have electrostatic forces causing a uniform circular motion. Think about an electron moving around the nucleus of an atom. So the key points from this video. In order to cause an acceleration pointing towards the centre of the circle in uniform circular motion, we need a force acting in the same direction as this acceleration. We know this from Newton's second law of motion. So, this force can be caused from a number of different reasons, such as a frictional force, a normal force, a tension force, a gravitational force, and possibly an electrostatic force. It depends on the situation of what force is causing this. It is not just simply a centripetal force is causing a centripetal acceleration. That's not correct. It is a certain type of force. You'll need to describe different situations where this is the case, so have some practice. Also, we'll get into a normal force in the next video.